my programming engineers. Welcome back once more to this frequency variator course. So today I'm going to be showing you about the start command, okay? Or the run command, which is basically another reference. But it's not really a velocity reference, but it's actually a start reference. So we're going to compare this to the velocity part. There are different sources, different ways that we can get that reference, that velocity reference. Through a drive, externally, on the potency meter, on the communication part, etc. Okay? By commanding the speed. So now what we need is to command the startup, which means where from am I going to command the startup? It's going to be through option number 1, which is variator keyboard, or external digital input, which is start stop, or the communication part. So which way am I going to command my drive for it to start? This is once the motor comes to life. So the motor is going to be able to receive voltage on the drive. And that voltage is going to be received just as long as I tell my drive that it's going to be ready, or that I press the start button. Okay, always in a drive we need to have the start button and the stop button in a motor. So that's why I need to tell my drive about that parameter. So I have to look for it in my manual, and I need to tell it through files in the parameters. I need to know what option is going to be the right one according to my application. So again, I can't select all these startup methods at once. So this is very important. This is actually step number 3. Commanding what way am I going to start my motor? So we're going to command this. And we have that option. So we're going to dive deeper into this. So option number 1, variator keyboard. This is actually a screenshot from what we did in the previous exercise. Okay, which was from the keyboard in our simulator. From the run button, we pressed it, and the motor started. Okay? So with our stop button is how we stopped it. That's how we were able to stop it. This is the drive keyboard, locally. This other drive, for Eden, has a run button and a stop button. So therefore, it has the same characteristics as every other drive. All we need to do is we need to find the right parameter. Okay? And then the command, the start command or the run command is, there's also the start command, which is the most common one, which is with external digital buttons, which is the run button. What's the color? Generally, it's green, as always. If it's green, it's run. So we need to be very careful here. We need to check this very easily. Why? If the button is regularly open, it means that it's waiting for a signal for it to close or for it to comply. So it's important that if I'm going to connect that signal externally, it needs to be external. And if it's a stop, it needs to be regularly closed. We actually have here a different type of button, which is an emergency button. So this is pretty important because I've seen many errors with this emergency stop button, and we need to be very careful. I've actually known many engineers I've seen many engineers that connect this stop button with an intermagnetic button, which is the drive voltage only to force it to stop. So at the moment when they activate this button, they add, I think it was, as far as I can remember, I think it was 2 regularly closed contacts. They press it, they obviously open up, and that's what causes the drive to stop. That is very dangerous. It's not right, and also we're stopping and starting our drive in a forced manner by diminishing the useful lifetime for the appliance. Okay, so we need to connect that emergency stop with a digital connection. And it needs to have that digital connection needs to have a parameter specifically for the emergency stop. But we're going to check into this further down, but with the communication part. Okay, so this is what I was telling you. I don't have any cable at all for stop or run or reverse or jog, nothing at all. Okay, so I have everything here connected with one only cable. And remember that we have our control part right here. And that one cable is going to go to our switch. Okay. This is actually missing. Well, this is a ring topology. This is actually my mistake. This doesn't have a switch at all. So it's going directly to the other port in our controller. If there was a star topology, that it would need the switch. And all other devices need to be added at the same time. Now here, it's connected by various racks at the same time. So what this topology does, and I explained this a little bit with our network course, which is if this side fails with communication, it needs to, the devices don't need to stop and they need to continue running so that there's no stop on the line. Okay, so this is a network issue. So what I can tell you is these start-stop commands, we actually transmit them through this cable, through an Ethernet cable, Profinet, or car bus, whatever you need here. So this is the command part for our communication. Okay, now what's next? So we're going to look for in our manual. Okay, where is it? Here it is. Actually, just below what we had previously, which is the E101, page 127, selection for frequency reference or velocity, is what we need. And now we're going to analyze for our advanced command. So here in Spanish, we call it advanced command, and it needs to be start command, depending on the region. So we know this as start command. Okay? So start command, this is how you look for it. And with this, you should be able to find it. But generally, where you see the velocity reference is where you can find that section. Okay? Remember that we need to be very skillful to find information that we need in the manuals. As you practice, you're going to learn this more and more and more. That's why I'm telling you this, guys. So we need to select B102. And on this side, we need to select option 0. If we select 0, then this means that our run and stop keys, they need to be on hold to on command, which means that we're going to choose this option, option 0, which means that we're going to listen to this current keyboard. So we're going to see on this side, we're going to select this option, B102. Okay? So we're going to select parameters, auto tune. We actually don't need this. B102. Let's see here. So run command. So you guys need to start getting familiarized with these numbers and these names. So we're going to use this run command. So this is the one that we're going to select here. And by default, we have option number 1. So remember that we were pressing and nobody was listening to this because we already had option number 1. So the program was already configured. Now, what is option number 1? With digital input parts for S1 to S7. So we're going to look into this in the future, but I'm going to explain to you that we have the same thing for our terminals, that they're already predefined. The A2 terminals, the positives for V, as in Victor, and it needs to be A1, so this has already been predefined. So we already have the path here to connect to our potency meter. So we have here our terminals, we have predefined warns so that we can connect our devices. So we also have sensors, buttons, and we have here the outputs. These are inputs, these are outputs, and every company has its nomenclature. So here on this side, Yaskawa, what they did, they'd rather call it S1, S2, S3, S4, and that's because they decided to do so. However, many other companies would rather call them as D1, D2, D3, D4, D5, D6, and D7, etc., and so on. D stands for digital in this case. So each company has its own rules. I've seen companies that name them as I for inputs, and I1, I2, I3, I4. So either one of them are correct, but it depends on the company. Okay, its function is the same thing. For Siemens, for Yaskawa, it's the same thing. So therefore, it's telling us here, terminals for digital input from S1 to S7, which means that you need to listen to these terminals. But first, we're going to try from down to up. We're going to try it upwards. So we're going to go back, back, back. And the velocity reference is going to listen to us for what we had established, which is through the potency meter or the external analog input. Okay? But the drive or the motor is not going to start unless we tell it to. Okay, so we're going to click on run, and it's running already. We're going to click on stop, and it's going to stop, which means that the start button is going to listen to it through our drive keyboard. So operator set up, run stop keys. It's going to listen to this in our setup. Okay? So something else that we can do is that we can change very easily the speed. Do you see this? That's why I'm telling you guys that you need to be very careful. You need to be very careful in leaving this potency meter for your customers. You need to protect your limits. Protecting your frequency, your velocity limit, so that you don't run into this, so that it's not as easy to modify. Because if you check this, right now we have a very, very low speed. 79 RPMs. But if I change it, it shoots up. Okay? This can actually cause a very big problem related to our system or our application. So then the keyboard works. If we press it again, and whenever it's in run, it's going to send a left. Whether it's on this side or up here. So it says that it's already running our drive. So why is it this left? To tell us if it's working or if it's sending our startup code. Because if I stop this, if I assign a 0 to this, it's going to stop. And apparently I'm going to say, well, we have a setup, 0, sorry. But if it's telling me here, you know what, it's not stopped, it's running. We already sent up a command. But not because it's in 0 means that it's stopped. So we need to be very careful here, because maybe an operator or an engineer or someone in maintenance has everything, all the voltage down, and they say, well, it's already stopped. So you need to be very careful, because we can cause a big accident. So we can play around with this status to indicate when it's in run, but so that it tells us through an alarm or an HMI or a special permission. So we can play around with this through our communication. This is done externally, okay? So if when I'm in 0, even though I know that it's under command, then I'm going to stop this, and it's going to stop blinking. So even if I assign some velocity to it, it's not going to listen to me. Okay, so if it's in run, it's still under the run command. As soon as I assign some speed, it's going to start spinning. So you need to be very careful with this. Okay. Now, let's head out to the other parameter options, which is 1, enter, 2, and now this is where we're going to collapse number 1, which is listen to the terminals for digital inputs from S1 to S7. So automatically, the first thing that's going to happen is it's not going to listen to me, even for our local keyboard, unless I force this. Now, how would I force this? Through this local button, and there we go. So if it's not forced, which is the variators that have these functions to force them, in case they need to move for emergency issues, or maybe that they don't know anything about drives, they don't know how to go into the parameters, or something that may have happened with the signals that they have to start it forcefully, then that's the point where they're going to press the local button, we're going to send out the signal, and that's when the drive can start. Okay? So this is what this is for. And it's not really listening to the commanded velocity speed. Commanded velocity reference. So we're in the most remote part right now. So this is used for very extreme cases, or some people that may not have used this. But ideally, it is by phone. Okay? So then the keyboard is not going to work, but what does work? The digital inputs. I don't know how the configuration is, but thanks to me adding this part over this button for my mouse, then now it's telling me forward run command. And this is S2, reverse run command. So from what I can tell here, simply by adding the parameters which have already been implemented, this is a 2-string connection. Okay? Guys, don't get frustrated with this. Next class, we're going to look into this. If it's 2-string, it's only going to listen to the instruction going front or going back. Okay? Only with this start button. And here, it should start back or go in reverse. So if the RPMs, in theory, they should be negatives. Yeah? Or the speed needs to be negative. Okay, so let's see here. So if I press run forward, it's going to turn. You see this? Why? Because it's listening to the terminals for digital input. Anything that I connected here, which in this case was a button, is going to go forward and it's going to listen to it. So we disable the button, and this is like a selector, and it's going to stop. If it doesn't get a signal, then it's going to stop. If it does get the signal, like a selector, like I said, with two positions, backwards and frontwards. If I had a button for this type of button, if I had a button of this kind, then not only should I have to push it, but I'd have to push it and keep it open so that my motor works. Now, what would happen if I go back right now? So first off, it's going to indicate that my drive is in reverse. Second place, my motor is telling me that it's in negative RPMs due to the inverted speed. Okay? It has the inverted RPM, so it's like identifying. And also the color changes to tell us that this is happening. Now, what would happen if I change my negative to positive? Well, first off, it's telling me that there's an error. There's a flaw, a failure. So it's like it's saying, well, if you can't make up your mind, I'm going to stop then. So how do I do this? How do I fix this? Reset and then run. So also in the future, we're going to look into alarms. Now, this is our second option, or option number one. Second option because it's 0 and 1. But the terminals for digital inputs, if we select this option, it's going to listen to what we have connected in our drive. Okay, which means here. Anything that we have here is going to listen to it. Okay? Done. Now, for example, we also have option number 2, which is memo bus communications through our PLC and our drive. Now, I had told you that this is not very likely because there's many PLCs for Yaskawa, and there's actually many companies who are really going to town on this. Okay? Now, this works for the rest of the drives. Whenever we are configuring the PowerFlex, you're going to notice that we should select this option. Now, this is a different manual. These are different parameters, but the same logic applies and is repeated in our drives. So don't say yet the memo bus communication, but now it's going to say Ethernet communication. Why Ethernet? Because we have the 525, which is the one that we're going to analyze in this course. So it has Ethernet communication. Every drive brand has its own different communication. Just in case for PowerFlex, it has Ethernet. Okay? And we also have our PCB option. Now, I was telling you that this option is an external option, which is basically designed for our drives, which is not very used in our. They have it in our PCB internally. And well, this is for the Yaskawa company, and they have to sell it to you by 4, so I wouldn't recommend this. So what I do recommend is that you need to know how to identify this option and then this option. I mean, we're not using it right now, but it is part of the options. If you want communications, I'm sorry, but you need to select the run command. In the velocity reference, you need to select this option. Okay? If you need to add a PLC. If you want to control it locally, this is for option 0. If you wanted to find it externally with the buttons for start and stop, that's option number 1. If you want communications, that's option number 2. Okay? So having said this, we're going to run with this class, and now we're going to explain our two connections within our start-stop option for our terminals, for our drives terminal. Okay? So everything that I'm telling you guys right now about is this one. There's no other more logic available to configure these drives. So this is something very important. If you skip this, if you go all the way to the end, and if you don't know this, trust me guys, you're going to get lost in this. So you need to pay a lot of attention, okay? And I'll see you guys in our next video. Big hug.